So good afternoon, everyone. We are back again with the second session of this last day, and we are having with us Madam Cynthia Menezes. She has been a very popular resource person in our last FDP also. So let me introduce her because many participants are there who had not been participant in this the earlier FDP. They are new to this FDP, so let me introduce her. Just give me a minute. Dr. Cynthia Menezes, Professor, Dean of Faculty of Commerce and Management and Director, MBA Department, Bangalore University. She published over hundreds of academic articles. She writes for websites and magazines. She delivered keynote addresses for several international and national conferences. She had been speaker for AICT-funded FDPs, HRDCs, and she is also the member of governing councils, academic councils, board of studies, and board of examinations for several universities and institutions. She has authored a book on operations research and has successfully guided 13 PhDs in management. He has been the nodal officer of sexual harassment prevention cell of Bangalore University. So today her topic of deliberation will be on cluster analysis. And I welcome you, madam, in this second version of FDP. And I hope that there will be a great learning session today. Thank you, madam. Madam, you can share now.
Yeah, I have shared, sir.
Can you share again, madam?
Can you see?
No, you share again. I stopped because I need to introduce you. No, that's right. You share again. Yeah.
I'm having some issue. Wait, sir.
There is a share screen button in the.
I know, but I'm not getting the screen. That screen.
Are you getting it now?
1 minute, sir. Okay. I had made it. Is it okay now?
No, it's not coming. Only the video is coming. Vicky ji, are you there? Yeah, ma'am, it's
Yes,
coming.
ma'am is coming.
Now it's fine?
Yes,
ma'am. Yes, ma'am.
Can I begin?
Yes, ma'am.
Good afternoon, everybody. Good afternoon, Dr. Deepjot Chowdhury. Am I very clear, sir?
Clear and loud,
the
madam.
volume of my voice okay?
Yes, ma'am. Clear. Perfect.
Clear. Okay. I will go ahead with the assumption that all is well as regards audio-visual presentation. And in case there is some kind of disturbance, kindly stop me in the middle. All right. Good afternoon, everybody. I'm very pleased to be here. I'm from Bangalore. I'm from Bangalore University. I'm the Dean of Commerce and the Director of the MBA department, a proud employee of Bangalore University. That's a short introduction of myself. Okay, now here we are talking about cluster analysis. When we talk about cluster analysis, it becomes important for us to understand what is the meaning of cluster, what is the meaning of a cluster, and what is the meaning of analysis, and why do we do it? Otherwise, if we do not understand the application of cluster analysis, whatever we do will be, will be just paperwork and numbers. So it is important to be able to do a proper inference of all the numbers that we have at hand. That is why we have to understand that a cluster is a small group of people and things. What kind of group? A group of similar things or people positioned or occurring closely together. Now, please note that I'm using the word occurring closely together. Closely means the distance aspect. All right. So when we talk about cluster, we are talking about clusters which make variables, any two variables with a minimum distance, they are brought together into a group called a cluster. So clustering basically works on the distance between two variables. Now, cluster, for example, is a natural subgroup of a population many times used for statistical sampling or analysis. Statistics of data points have similar numerical values. Now, I will go ahead. I need to tell you a little more about cluster. For example, you may be having to come across a cluster called an industrial cluster. An industrial cluster is a geographic concentration of firms in the same industries. So it could be specific, for example, if companies are co-located in a specific geographic region, it could be a cluster. Or if they provide a related group of products or services, it could be some healthcare services in a particular place or all over the place. It could be someone who gives a particular, how many hospitals or healthcare centers in India provide cardiology treatment, all right, heart transplants, etc. So they could be a related group of hospitals. It is also built on the collaboration to address a common problem. For example, if we are going to address medical tourism of foreigners in India, then it could be all the hospitals, a cluster of hospitals that provide excellent medical care for NRIs or foreigners, etc. Sometimes a cluster can be driven by externalities like specialized knowledge. Someone, say for example, Dr. Deviation is specialized in cardiology. So like that, someone can be specialized with nerve surgery, or it could be nerves of the brain. My husband's brother is a neuro-oncologist in the US. For example, it means he is a cancer specialist of the nerves of the brain. So this is specialized knowledge. It could be skills. He has sent me a video where he is operating on the brain of a patient, and the patient is playing the guitar. He's sleeping and is playing the guitar. So some kind of skills, and then infrastructure, all right, and supporting industries. See, supporting industries could be ancillary, auxiliary industries. For example, if you see around Tamil Nadu or Chennai area, a lot of, it has become an automobile hub. You know, India itself is an automobile manufacturing hub for these cars, which are foreign manufacturers. So here what has happened is, see, once Ford came to Chennai, and then the local people built, supporting industries. Like in a car, you don't get everything manufactured by the original manufacturer. There are OEMs, original manufacturers, equipment manufacturers, who, for example, the chassis of the car, or the tires, or the fenders, or the windscreen could be manufactured by somebody for the first car, original equipment. All right. So these are ancillary industries. So there could be a cluster of ancillary industries, etc. So it includes all stakeholders within a locality. So clustering can be considered as the most important unsupervised learning techniques. So that, why do we call it an unsupervised technique? Because if you consider, so as every other problem of this kind, it deals with finding a structure in a collection of unlabeled data. You see, for example, I will show you the difference between classification and clustering. So you will understand that classification is supervised, though some statisticians say it is unsupervised, or they even say clustering is supervised, but it isn't. Actually, classification is supervised because we just say, for example, when you select a gender, you already are classifying. So it's a supervised technique, whereas cluster is based on the distance between two variables, and this is an unsupervised technique. It is the process of organizing objects into groups whose members are similar in some way, so that there should be adequate similarity between members. As we go ahead, you see that iteration happens in clustering. Iteration means repetition, so that when the your software program keeps on clustering, you will get variables which are closer and closer to each other. And there are various ways as we go on, you will see. A cluster is therefore a collection of objects which are similar. See, if you have a cluster, everything, all the objects inside are similar to each other. Imagine you have another cluster, two clusters. So there are two concepts to clustering. Everything within is similar. Everything without, that is outside, is dissimilar. All right. This first cluster has everything similar. The other cluster has everything dissimilar to this one. Within that cluster, there are similar objects, but these two clusters are dissimilar, have objects which are dissimilar to each other. All right. So here we go. So what is clustering? It is also called unsupervised learning. Sometimes statisticians say classification, but classification is essentially a little different because you label the cluster, like if you call it cluster, you label the classification. Okay, again, please remember there are two aspects to clustering. There should be within the class or within the cluster, there should be high similarity and there should be low interclass similarity. Or between two classes, there should be very low between cluster similarity. Within cluster, that is intra-class, there should be high similarity. Between, there should be low similarity. Now, finding the class labels and number, 1 minute. Finding, wait, 1 second. Finding the class labels and the number of classes directly from the data. More informally, finding natural groupings among objects. As we go ahead, you will be able to understand. Now let's go on. Why do we cluster? See, why we cluster? 1 second. Why do we cluster? To make things simple. So see, clustering is not the end all and be all. Clustering gives you ideas to do more work. Clustering is one of the first things that we need to do. After clustering, you can do ANOVA, you can do correlation, regression, anything you can do. But to simplify data, you require your clustering. Also, you detect a pattern, that there is some similarity between the opinions given by the respondents. So you detect a pattern. So the third, it is useful in data concept construction. So suppose you do the clustering and then you find that, okay, I can do a hypothesis based on this cluster. So data concept, construction of the data concept is possible with clustering. Okay, and it is an unsupervised learning process. You don't say cluster like this or cluster like that. Okay, if you were to say cluster it according to this or clustering according to that, then it would be supervised cluster, supervised data. So what is good clustering? Yes, I know I'm talking too much about clustering, but it is important for you as researchers to understand the correct and deep meaning of clustering, because otherwise you will go on to misuse it. So there are, as I said, there's an internal criterion where the similarity should be very high, and the external criterion is interclass. Between two classes or two clusters, the similarity has to be low. Okay, the measured quality of a clustering depends both on the document representation and the similarity measure used. Okay, now one of the questions, why clustering? One of the questions facing businesses is how to organize huge amounts of data available into meaningful structures. So this is an cluster here, is cluster analysis is an exploratory data analysis tool. It's an exploratory tool which aims at sorting different objects into groups, different kind of objects into groups in a way that the degree of association between two objects is maximum if they are belonging to the same group, and minimal if they between two objects, say object A in cluster 1 and object B in cluster 2, the similarity between them is low, but object A with other clusters, it is high within the cluster. So clustering is an undirected data mining technique. What is data mining? Talking about data within data. Okay, I'll give you an example of data mining in case you all don't know. See, IBM had given IBM had given cable connection to UK, all over UK. It had a monopoly, okay? IBM had a monopoly for in giving cable connection in the UK. What happened is, IBM was making a lot of money. So they said, let me give something else to the people, some kind of, some more thing to what they were, for what they were paying. So IBM did data mining. For example, imagine an Indian family in the UK is watching a cricket match, and they like, and every Indian family, they found that they liked movies, and people liked, there were some cricketers whom they liked. Let's say Virat Kohli. Someone else is batting and Virat Kohli is sitting in the, he's sitting on a seat and all that. And maybe he's having some drink, or he's sitting and he's thinking something. So what they started doing is, if you think the whole screen is there, no, a small square on the bottom of the screen, they would show Virat Kohli, because they knew that Virat Kohli, actually it was a little time ago, and that time it was Tendulkar. So they would show Tendulkar in one corner of the screen for enhanced delight of the customer. So this was data mining. How did they find out? Because they found that people were, looking at, and even in a movie, like if you see the Friends serial, for example, it is replaying so many times, you will get one friendly fact. Okay, why do you give a friendly fact? You give a friendly fact because you're curious about Jennifer Aniston, or you're curious about the other actors whose names I cannot remember. So something about Jennifer Aniston, something about, this is a friendly fact. Why? This is because data mining has taught you, because you have done analysis on data, and it has taught you that there are people who are fond of Aniston. So clustering is an undirected, because I said unsupervised data mining technique. This means it can be used to identify hidden patterns and structures in the data without formulating a specific hypothesis. As I said, once you do clustering, you will get ideas to form a hypothesis. There is no target variable in clustering. We are not saying, do according to gender. Then it becomes classification. It's not clustering. So there's no target variable in clustering. It may be just an attempt to understand the different buying behaviors of some customer base of a company. It can be used to discover structures in data without providing an explanation and interpretation. It won't give you an explanation and interpretation. It will only show you that there are clusters. How many clusters are possible? What is the strength of the cluster? It will give you. Cluster analysis discovers patterns without explaining why they exist. The resulting clusters are meaningless by themselves. They need to be profiled extensively to build their identity. That is, to understand what they represent and how they are different from the parent population, from the whole population. It can be a powerful data mining tool for any organization that needs to identify discrete groups of customers, sales transactions, or other types of behaviors. For example, insurance providers use cluster analysis to detect fraudulent claims, and banks use it for credit scoring. I'll explain. So you have market segmentation can be done by grouping people into clusters. Like you can say, willingness to buy, purchasing power. Purchasing power is possibly given by income. So I will show you how debt versus income, how you can cluster and say which is the high risk category cluster and which is the low risk category cluster. So now you just follow this. As I go on, I'll show you. Sales segmentation. Who buys wheel? So wheel, for example, is bought by people who are in the lower middle class. Who buys Ariel? Who buys Tide? Okay. Who buys the other whatever soap? So this is, you need sales segmentation. Credit risk. I'll explain to you with a, excuse me. I'll explain to you with a diagram of, people, it was on the y-axis you have debt, on the x-axis you have income. So what happens when you have low debt and low income, high debt and low income, high income and low debt? I'll explain to you later as we go on. Operations, high performer segmentations and promotions based on a excuse me, person's performance. There may be in insurance, some people like to claim, some people never claim a vehicle insurance. So who are those who are likely to claim? This is also very interesting. But how they use it in the insurance, how they make you pay same premium for everybody, whether you're a high maintenance or a low maintenance, this I can't figure out. And that is, I think, their strategies. Then city planning, in which area, what happens, what is the value, something like this. Clustering of politicians' houses so that they can get 24-hour electricity and water, and we don't. Not that we don't. In Bangalore, we are pretty happy. The government, the Karnataka government, takes care of us really well. We have a good government, as well as our BBMP, local metropolitan company, takes care of us pretty well. I shouldn't be complaining. And the drinking water, everything is pretty good in my state and my our capital. Then geographical. Okay, geographical, that I think you will understand. We'll go ahead. See, I will not go too much into customer profiling. I'll give you one example. See, there was a particular t-shirt, I forget the name, Proline or something, which came to India. So in India, there are t-shirts which cost us 100 rupees. For Holi, you get in metro 100 rupees t-shirt, which you're supposed to wear and make it dirty. And you can get t-shirts for 2,000, 3,000 rupees. Now this Proline was a t-shirt which costed, when it entered, I'm talking about 10, 15 years ago, 2,000 was their, was their rate. So who in India 10 years ago will buy a 2,000 rupees t-shirt? So to advertise, it became necessary for them to profile the people who are buying this t-shirt. So what they profiled is, they said this man who's going to buy my t-shirt is between 25 and 30 years old, or maybe 35 years old. I forget that upper limit. I think 25 to 35. He earns so much. They gave a income bracket, and they said he is typically a married man maybe, and he has maybe 1 or 2 children. I'm talking about 10 years ago. There are different demographics happening now. People don't want to get married. People don't want to have children. This is the current trend. I'm talking about 10, 15 years ago. So they said this is the young yuppie. They called him yuppie. Y-U-P-P-Y. How they profiled him? Between 25 to 30 or 32 or 35 years old. He would get so much income. He would be a person who doesn't work on Saturdays. He would be a person who works for 5 days a week. And then on Saturdays, what does he do? He goes to a club. Okay. He goes to spend his time because he needs networking or he needs relaxation. So he goes to a club. So when he goes to a club, he needs to wear a t-shirt. Now he can't wear 100 or 200 rupee t-shirt because his dignity and his profile is such. So that time they needed to profile a customer because they wanted to sell the t-shirts in the areas where he goes. Now I will not go, I'll go into the next slide and I will explain to you. You can read the slide. I'll explain to you in my own way. How do you, why do you need to profile? For example, you go to a mall. We have a mall here owned by Malia, UB City Mall it is called. If you go there, the shoes are 20,000 and the shirts are, I don't know because I never tried to buy. I cannot afford the t-shirts. The perfumes are like that. Okay. Once someone was telling me, ma'am, I saw Ambani, one of the Ambani wives shopping there. I think the young Anil Ambani's wife, Tina Ambani was shopping there and something like this. So In that mall, everything, see, that's why you need to profile and segment a customer. Who goes to buy there? If a person who can buy in UB City Mall can buy a pair of shoes, he or she can afford to buy jewelry there. He can afford or she, clothes there, perfume, accessories, everything. So whatever shops you have in UB City Mall are all those premium kind of shops. Okay, premium kind of shops. There's no, like you never even dream of getting 1,000 rupees shoes. They are all about 20, 15,000, and dresses are similarly like that. So you understand the why clustering, and why clustering leads to customer profiling. This is in marketing. If you're doing data and the business analytics, actually I'm writing a book on business analytics, you find that clustering is one of the basic forms in marketing where you can do easily segmentation. Now this one also you can read by yourself because I have already explained. See, targeting by specific segment. See, if I go to a mall, say Forum Mall in Bangalore, and if I can afford a pair of shoes there, say 2,000, 3,000 or 5,000, then I can definitely afford to buy a sari there. I can definitely afford to buy jewelry there. I can afford to buy accessories. So when you profile a customer, accordingly you can have a lot. If I go to a mall, I say there is a wedding in the family and I want to buy the whole gamut from shoes and jewelry and accessories, etc. Perhaps a tailor also to do the stitching. Then I would like to go to one place. Okay. Now, another example I want to give you is when you go to a petrol bunk. Yeah, I know how to do clustering. I'm doing, don't worry. But I need to explain this because I'm a management teacher. Otherwise, there's no use doing clustering. Just doing clustering for the sake. I have everything ready. Don't worry. Just be with me for a while. So you have gone to this one, petrol bunks. In petrol bunks, you have seen shops. What do they do there? What do they sell there? They sell you coffee or some, I think so, because I've never gone there. I just don't like to get on from the car in the petrol bunk. So you can get possibly coffee. They gave me for putting, in Shell petrol bunk just last week. I said 3,000 diesel. So yes, I run a diesel car. So they said, ma'am, put 3,500. There is sanitizing wipes free. Okay, so according to the profile of the customer, see, someone who drives a car would want sanitizing wipes. I cannot get down and wash my hands every time. I need a wipe to wipe my, of course, I'm the only one driving my car, but I want to wipe the, wheel. I want to wipe, suppose somebody has opened, I'd tell my attender, please bring, I've left something in the car, please bring. So he or she has touched the car handle, and I've touched the car handle. So I want to sanitize the car handle where I keep my arm. We are always in sari, so this part is, exposed. So I want to wipe with a. So they have profiled who is going to use the sanitary wipes, and accordingly they are offering it free. And for a person who can put 3,000 diesel, 3,500 is not a big deal. So for 3,500, they've given the sanitary wipes free. Next time, even if I don't want to put diesel and I want sanitary wipes and I like these Shell, I'm going to stop near Shell and wave and say, please give me a packet of sanitary wipes. You see how you customer segmentation and customer profiling through clustering helps in this one. Okay. And even transaction analysis. This is exactly what I just now said, how a person behaves. When next time I want a packet of sanitary wipes, there's disinfectant wipes, disinfectant, what do you call it? All of us are using it, no? Sanitation sprays. So those, when I want to buy, I may probably stop near Shell rather than go to a supermarket, walk inside, park there, walk inside. It's easier for me to drive in through Shell and buy a pair of sanitary wipes, and they'll bring it to me to the car. So this is the way marketing budget, that is advertising budget and the promotion budget, can be optimized and the returns and returns on investment can be maximized. So another thing is, this is to detect who is together in a cluster. Also, you have outliers. I will show. See, normal, the normal curve, whatever people behave is shown in a normal curve. If there is someone outside the normal curve, why they are outside? This helps in, for example, tissues. The way the tissues, features of tissue cells are put in a normal curve. If there is something that is abnormal, you can detect it through clustering. See, this is the medical usefulness. Okay. Now, please remember, clustering makes the data amenable to other techniques. It is not the end all and be all. Okay. It makes it amenable to other techniques. Regression, correlation, ANOVA, everything can be done. You may tell me, ma'am, what is the difference between factor analysis and you can do factor analysis too, where you get a group of factors that are more important. So here cluster also is the same, but clustering does on distances, and factor analysis on deviations from the mean. All right, on deviations, factor analysis on deviations, clustering on distances. Okay, remember that. So you can explore patterns, etc. I think I should go ahead now. Even prospect acquisition. Suppose you put up a kiosk in the club that the young yuppie goes to, and you sell t-shirts there. Then possibly they will sell more than you go into a mall, and people may not buy in the mall. A mall where people like me, middle class people go. I may not want a 2000. I may want one t-shirt, but I may not want 10. So what is the profitability? Profitability for the marketer is when I buy 10 t-shirts. So one t-shirt here, one t-shirt that doesn't really help. It's like you can sell any small car. You need to sell thousands of cars per year. But if it's a BMW or a Merc, then you may need to sell 20 per year, and that you make your profit, less than 20 also maybe. So this is the way you have to cover it. Geographical. Sometimes you also do cluster sampling, but I will not go into that. You can just Google it. I don't want to waste time. Now, here we are. Here, classification and clustering. See, classification, you first only you say, okay, I want it classified as gender or age or educational qualifications, etc. So it is a preconceived notion. It is a supervised technique. Whereas cluster is not like that. Cluster is found on its own. You don't even know whether there are clusters till you work on it. Okay, you see this classification. Here was what I was trying to tell you about. You see age, this is the age, and somewhere else I have debt, later on I have debt versus income. So you see, when your age is less and your salary is less, you are obviously in the high risk customers. You classify them. Here, when your age is more and your salary is more, the risk is lower. So here, in clustering, you get a cluster. Okay. Here you just, this line can keep moving. It can go up, it can come down, it can go on and on, iterative, till you get the proper clusters. Okay. Repetition can happen. Now you look at this. This is very interesting. Please watch it for a while. You have, four-legged, two-legged animals. How you classify them? If you can see in the next one, two legs have become cluster. These are all two-legged on the left side, cluster, and on the right side, they are all four-legged. All right, just watch it. Sorry, that was a mistake. So I guess you can see it later. Okay, so classification and this is supervised, unsupervised. One more this thing. See, I've brought a lot from the internet. Gratitude to the internet. So what is cluster analysis? You have multivariate, it's a multivariate technique. You have many variables like respondents, product features, etc., etc. It's the meaning of group, it's a means of grouping records. What is cluster? You analyze and make it into clusters. That's what clustering is. And what is a cluster variate? A cluster variate, 1 minute, represents a mathematical representation of the selected set of variables which compares the objects' similarities. Let's go on. Types of clusters. Now you have, you see, there are something called hierarchical and non-hierarchical methods. In the hierarchical means what? Hierarchy. You do a cluster, iteration, again a cluster, better cluster, iteration, better cluster, like that. These are hierarchical methods. The others are not. You say K, you give me K number of clusters. Okay, you tell them, I want 2 clusters. By default, you get in SPSS 2 clusters. So I want 2 clusters, you may say, or I want 3 clusters. So K should be less than N, all right? For example, N is the number of objects that you see. You all know statistics, okay? So here we have hierarchy. We'll go ahead. Cluster analysis, I will not go into this. I think I've said enough and more about a cluster. So a large number of cases, and which can be observations across respondents, and reduce them into smaller groups or clusters. Okay, here. See, all these methods are not important for us currently, but I need to explain some of them. All right. So here we are. Partitioning method. See, we are given a database consisting of n number of objects. So you want to partition them into k number of clusters. So k has to be less than n. So each group contains at least one object. Each object must belong only to that group. Now here, next you come to hierarchical methods. As I said, first it's clusters, and then it measures the distance between the objects in the cluster, and then it starts breaking the cluster into other clusters such that within a cluster, the distance between the objects is minimum. All right. So it creates it keeps on decompositioning. All right. And here we have something called agglomerative approach. It is the bottoms up approach. We start with each object. Imagine n number of objects are there. So you have n number of clusters initially. So then they start merging. So you'll find in n there are some, some objects which like each other or look like similar to each other. So you start keep on clustering, etc. As I said, it's basically the hierarchical approach, iterative process. So you get into clusters at the end of it. Now, next one, divisive, is the top down. Think of all the objects in the same cluster. See, here in the agglomerative approach, different clusters, n number of clusters, and then you get the required cover. Here, all objects, n objects in one cluster, and you break it up. Just top down and this thing. So this is the next one. Density, I will not go into this thing. I don't think I have much time because I have other things to explain. This one, see, grid based. You can form a grid structure, model based. But for us, all this, if you go into it, you'll get confused and say, what am I going to use? Why? So what is necessary? Everything in SPSS is not really necessary for everybody. So like in your phone, all I use, my phone is for making calls and WhatsApp and messaging and, maybe payments. So there must be, my son says, Mama, iPhone, you have to use this, use that. Even Siri doesn't, I don't talk much to Siri. She must be angry. The phone, the Siri in my phone must be really angry because I'm a total stranger to her. Why I'm talking all this is just for a light conversation. Everything in SPSS you don't use, just like you don't use all the features in your phone. That's my answer if you ask me a question, because I wouldn't know any other answer. So here you have clusters. See, this is the debt here. This is low debt here. This is naturally high debt and income. So you see here, cluster 2 is consisting of people who have low debt and low income. They know how to live within their means. Here you have this cluster, which is dangerous. Debt is high, but income is low. Cluster 1 is high risk people. You see, the debt is high, yeah, and the income is only so much, not even, see, within this. Yeah, high risk. These people are cool, okay. Income is high, and the debt is low. See, debt is only up to here, okay, but the income is also high. So these people you can easily give, like in when you go to the bank, give a loan, give what? Give loan, sorry. To a bank, they'll ask you to, and you want a personal, loan. They'll ask you, do you have a house of your own? Do you have a salaried job? Is your job private, in the private sector or the government? Because everyone in India thinks government sector is safe job, and it is actually. And then they'll ask you whether you have a car, do you have a two-wheeler, do you have, certain things, and for everything you get points. So if your points exceed a certain number, your loan is easily sanctioned within 24 hours. So these are the people who come there. And how do you cluster them? By ticking. I have a car, I have a house, I have a salaried job that the government of India is providing, or the government of Karnataka is providing. So these are these guys. These are low debt and low income. These are sort of okay, because they know how to live within your means. These are the dangerous people that you have to watch out for. Your debt, the debt is high and the income is low. See, income comes within this. See, watch this thing. Okay, here we are. Now there is something called K-means, by which I just spoke to you about it, isn't it? Clustering into K number of clusters. So this is one illustration where before and after. All right. Now, in cluster analysis, you will get a cluster dendrogram. Okay. How do you analyze this? Before we go ahead, let me just tell you, this is a very interesting thing. See, here you will get a measure. Okay. Obviously, you have 0 to high. So I can say this height, tall over here and short over here. Okay. So all the shorter people, if you get something like this, okay, in the lower part of the dendrogram, then you say these are shorter people. Just to explain to you, I'm telling example. Suppose I'll repeat, I have a sort of a continuum in the form of an arrow. Wait 1 minute. Over here, I have an arrow coming from up to down or down to up. So let's say here is taller people. Let's say here shorter people. So if I see the highest horizontal line, sometimes it's a vertical line, I'll show you. Then I'll say these are all taller people clustered together. And the lowest, I will say these are the shorter people clustered together. Just keep it in mind. There are more dendrograms coming. Okay. Now see, you must learn to interpret a dendrogram. It's very nice. Okay. The key to interpreting a dendrogram is to focus on the height in which any two objects are together. Now let's take a look at this one. This is E and F. They are together, right? Okay. So E and F have great similarity. Next, we will go here. D, E, and F can be clustered, but they have less similarity. You can see A and B here, they have great similarity. A cluster. I could say this is one cluster by itself, A and B, and these fellows have another cluster. If I'm going to do hierarchical this thing, no, it will come like this. E and F are best cluster, then followed by D, followed by C, etc. Don't be too worried. We have interesting concepts coming now. See, before we go ahead, you must remember there are something called outliers. Outliers are, see, all these blue dots are data sets. It could be 2 data sets, etc. And it could be easily, this could be the correlation or the regression line. But you see this fellow outside. Like we have students, no, outstanding students. When you get angry, you can say, please leave the class. He'll be an outstanding student. He'll be standing outside the class. Am I right? I hope my English is right. He's outstanding student, isn't it? So here we have an outstanding fellow. He's an outlier. All right. This is also an outlier. He doesn't belong in the group. So watch out for these fellows, okay, when you do the analysis. Now, understanding the basic principle of how clusters are formed and naturally the hierarchical nature of the process. Each case begins as a cluster. Here I told you, in hierarchical, if there are n number of objects, there are n number of clients in the first step. N number of clusters in the first step. Find the two most similar cases, here A and B, by looking at the similarity coefficients between pairs of cases. I'll explain that. The cases with the highest similarity are merged to form the nucleus of a larger cluster. Then you merge and you merge and you merge, etc., etc. Let's go on. How are clusters made? Now, this is from a particular website, and gratitude to that website. But here we start. See, you can see here, look at these two fellows. They are exactly same. Look at the third one. This one is same, but these have gray stomach. This fellow has a white stomach. So that is the dissimilarity. But in looks, he is exactly, let's say he only, is exactly the same. All right. So the next cluster will be, the first cluster will be these two fellows. If you can see, as I said, the continuum, watch this, the similar and the dissimilar. So if your horizontal line is down, then you are dissimilar. Higher degree of dissimilarity. If this is the center, anything below this has high dissimilarity. If this is the center, anything above it is high similarity. All right, because we have put your similar and dissimilar. Look at these two little fellows, they are very similar. So here is the horizontal line which connects them. All right. Now let's go to the next one. We want to cluster others. So we cluster this fellow. Where am I? Sorry about that. You cluster this fellow, but he has a white stomach. So when you join him, the similarity goes, dissimilar is here. So the dissimilarity comes down. You understand? Since it is dissimilar, you have the horizontal line that is below this line. Similarity is here, dissimilarity is here. Let's come to the fourth fellow. He looks similar, but he is not gray, he is white and has a black stomach. So again, the dissimilarity, the dissimilar is here. So the line that joins 1, 2, 3, 4 will be still lower. And then comes this little Calvin. He is not at all a bear. So he is hardly part of the similarity. So this is single linkage or slink, latest, nearest neighbor. I hope you understand. This is a very cute diagram. Thanks to the author. I've given you here, Discovering Statistics. I took from that website. Okay, so now I think you understood here. This is about, I've brought this diagram again. This explanation is for the same diagram of the previous slide. All right. So I think there are several important points here. The first is that the process is hierarchical. The results we get will very much depend on the two cases that we chose in the first starting point. Second, cases in a cluster need only resemble one other case. See, this third fellow should resemble this fellow or this fellow. A or B. If this is A and this is B, C should be similar to B, or C should be similar to A. Okay. Finally, the diagram we have drawn connecting the cases is known as a dendrogram. Okay, already I've told you. Now let's go to complete linkage or farthest neighbor. This is very interesting. To begin with, the procedure is the same as the simple linkage, in that initially we look for two cases with the same similarity. That for us, let it be A and B. And they form the nucleus of a cluster. The second step is where the difference in method is apparent. Rather than look for, in the first case, I said C, the outsider, should resemble A or O or B. Here, C should resemble A and B. Okay. Here, C should resemble A and B. There should be something common between A and B that resembles C. Okay, simple. This is the complete linkage. All right. Next, average. This is even more simple. I said C should resemble A or B in the first case. In the second case, C should resemble A and B. Here, there should be something average between A and B that resembles C. Or C should resemble the average between A and B. Simple. All right. Okay. Next, Ward's method. Now, Ward's method is what we are going to use when we use SPSS. Okay, we are going to use Ward's method. The example I have given you, exercise, is on Ward's method. Now, what is Ward's method? Ward's method is slightly different. It is considerably more complex than the simple linkage. Now, the aim in Ward's method is to join cases into clusters such that within one cluster, the variance is minimal. All right. Within a cluster, the variance between the people or the variables in the cluster, the variance, okay, is minimal. Each case begins as its own cluster. If you have n number of items, n number of clusters. Clusters are then merged in such a way as to reduce the variability within the cluster. As I said, hierarchical. Okay. So you find some similarities, you make two clusters from n by 2. Two clusters from n items. Then you make it 3 or you make it 4. And each cluster, the variability between variables is less. Between the members of a cluster is lower. Okay. Each stage, the average similarity of the cluster is measured. The difference between each case is within a cluster, and that average similarity is calculated and squared. Like how you do standard deviation, no? If all the data sets, all the items in the data sets, I will call as x1, x2, x3, x4, to xn, then I'll say x minus x bar, the whole square root of, how do you do the deviation? Root over x minus x bar, the whole squared by n. So similar to this one. All right. Next, we have one interesting dendrogram here, which I want you to understand before we go ahead. Just let me check the time. Oh, it's 1 o'clock. I have only finished 45 minutes. I have lots of time. Okay. This is a dendrogram. The following is the results of the, okay. For example, this is the group average consulting. I took it from this software. All right. Okay. Now see this, the horizontal axis. Here it is a slightly different. The horizontal axis, all these, represents the distance or dissimilarity between the clusters. The vertical ones represent the similarity, vertical represent the objects and the clusters and the similarity. See, our main interest here is in similarity and clustering. Each joining of two clusters is represented on the graph by a splitting of the horizontal line. This horizontal line is split like this. This horizontal line, little fellow, is split like this. This horizontal line is split like this. Do you understand? Give me a moment. Okay. Each joining of two clusters is represented by on the graph by the splitting of a horizontal line into two horizontal lines. The horizontal position of the split, shown by the short vertical bar, gives the distance between the two clusters. The vertical bar, see, we are talking about the main line is the horizontal line, and the vertical line gives the clusters. Now, I told you, if the line is similar for 2, then you have a nice cluster. See here, watch this. 11 and 9 is a good cluster. 10 and 8, 9 and 16. All right. These are small fellows who are very much related to each other. We'll go and see how many clusters are there. This whole thing is one cluster, 12 to 7. 22 to 14 is another cluster. And wait, 22 to 13, I'm sorry. And 6 to 1 is another cluster. All right. Wait, who are the outliers? See, you see here, this says 6 and 13. You see this 6? 6? See? Because of this 6 number, variable 6, this line is generated. All right. Otherwise, if this was here, it would have been an excellent cluster. In this cluster, in this particular cluster, Mr. 6 is the outlier. Same thing if you see from 22 to 13, Mr. 13 is the outlier. See? Everyone else is within the cluster. All right. This is how you interpret. Now let's go on. In SPSS, cluster analysis can be found in that analyze place. You know, we all do analyze, no? Just let me get on the phone also. Okay, 1 second. So here we are in SPSS, cluster analysis can be found in analyze, classify, etc. So we do with the k-means cluster, the 3 things, 3 ways we do. One is k-means cluster, second is hierarchical cluster, and 2-step cluster. See, k-means I already told you, so many clusters, how many clusters you want, you can tell. And then hierarchical structure, it takes n number and then it combines, breaks down, etc. So the 2-step is what I have done. First we will do k-means, and no, sorry, first we will do hierarchical, and then the same thing we'll do k-means. All right. So that is the 2-step clustering. Let's go on. See, look at this. Cluster analysis works upwards to place every case or every variable into a single cluster. Therefore, we end up with a single fork that subdivides at lower levels of similarity. Look at this dendrogram. Watch carefully. I'm going a little slow so that I want you to understand the dendrogram. The fork first splits 2 separate cases, 1, 4, watch my cursor, 1, 4, 7, 11, 13, 10, 12, 9, 15, and 2. All right. The second division is here. 1, 4, 7. If you can see, this one. I'm unable to see because, the pictures are coming here. So the second major division, you can watch this. Watch these lines, the horizontal lines. The second is to split the first fork into 2 further clusters. Which was the first floor? 1, this one, 1 till 3. All right. That is this one, this line and this line. Then the second major branch is to split the one branch of this fork into 2 further clusters. This is hierarchical. This division separates 1, 4, 7, 11, and 13. This one from, see here, 10, 12, 9, 15, and 2. These are one more. And here you have another structure, cluster. So this is the way hierarchically it goes on. Don't be too worried. I will explain to you. Now, here I have brought you, this picture is purely from a database on the internet. Okay, it's from an internet thing. I'll explain with this and then I'll show you what I have done. I have no compatibility on my Mac with the SPSS. I have to use another laptop, but the other laptop doesn't have powerful camera, etc. So I have worked out and I brought you pictures, specific pictures. You can ask me anything in it. Okay. So here, this is a typical, SPSS. This is how it looks. You go into analyze. Then you go into classify. Of course, you need a data set that you have made .sav. Okay. So you have under analyze, classify. Classify as will go into hierarchical structure or cluster. Okay. Next, the hierarchical cluster analysis, 1 minute, follows 3 basic steps. Calculate the distances. Okay, first it calculated the distances between variables, links the clusters, and chooses a solution by selecting the right number of clusters ultimately. First, we have to select the variables. Which variables you want to do? In this one, as I told you, this is from the internet. These are, they want to choose grade on math test, grade on reading and writing. They want to cluster them. Find out how you get clusters within them. So in the dialog window, this is the dialog window. If you click on these and then click on this, because this fellow will be pointing like this fellow to the right. So before you click, you'll have this arrow place, you have to click this, and then you have to select here, and you have to click here, it will move here. All right, simple. Next. In the dialog box, there's a statistics box on the right here. We can specify whether we want to output the proximity matrix. Proximity means closeness. Distance, calculated in the first step of the analysis. And the predicted cluster membership, again, leave everything on default. Don't be too worried. I know you're a little worried because I'm doing this. Don't worry. Once I finish 2 or 3 more slides, I'm coming to the diagram that I have done and my own example. I'm going to explain thoroughly. Please don't be worried with this slide because I'm worried. Okay, then you have click on dendrogram. Now here on the right, you have statistics and you have plots. So you click on plots. When you click on plots, you'll get dendrogram. So you know what is the dendrogram. I already showed you. Okay. It allows us to identify the appropriate number of clusters, etc. I will show you another dendrogram too. Now, the dialogues box asks you method. In the method, as we call it, squared Euclidean distance. I will explain what it means. First, we need to specify the distance measure and the clustering method, what clustering you want. First, we need to define the correct distance measure. SPSS offers us 3 large, one for interval. See, you have data, ordinal data, binary data, interval data, etc. If you want to know what is the meaning of ordinal, interval and binary, I've brought you 2 slides at the end of this presentation with proper examples, so you can thoroughly understand what is the meaning of this different types of data. I'm sure that you already know, but if you're a little confused, you can go there. I do not have so much time as to explain the types of data. All right. For interval data, the most common is the square Euclidean distance. You know interval, no? 0 to 10, 11 to 20, 21 to 30. This is, so you have to take the square Euclidean distance. Now, what is the Euclidean distance? It is based on the Euclidean distance is between 2 observations, which is the square root of the sum of the square distances. Now, don't be confused. You know the deviation, no? Root over, that is the square root. Okay, of the summation of, how do you do standard deviation formula? Sigma is equal to root over x minus x bar the whole squared by n, root over x minus x bar the whole squared. That is sum of each observation minus the mean the whole squared. That is the square you have, and you have the square root divided by n. So you have the square root of the sum of the squared distances. Why do we do squared distances? Because sometimes if you get a positive and a negative, it cancels itself, and then you won't get a proper answer. So that is why in statistics, we use squared distances, because -1 into -1 is 1. -2 into -2 is 4. But if you get -2 and +1, you will get the answer as -1. So it won't be correct. It cancels itself out. That is why we use the square. Okay. Since the Euclidean distance is squared, it increases the importance of large distances while it weakens the importance of small distances. All right. Excuse me. Okay, let's go on. If we have ordinal counts, we can select between chi-square and a standard chi-square called phi square for binary data. Now, what is binary data? Okay, the binary data is where you use 0, 1, which the computer can understand, zeros and ones. See, it's here. Binary data is a type of data that is represented or displayed in the binary numeral system. It is the only category of data that can be directly understood and executed by a computer. One of our teachers used to go to the switchboard and say, put it on and say, this is 1. Put it off, this is 0. So this is the way computer understands, he used to say. So, well, I don't know. I don't advocate that, but it was cute. It is numerically represented by a combination of zeros and ones. You know that. Okay. For binary data, the squared Euclidean distance is commonly used. So here we are. You can use phi squared, you can use chi squared. Okay. The chi-squared statistics enables to measure the degree of association. What do you use a chi-square for? To find whether there is a significant difference between A and B. So it enables to measure the degree of association, whether there is a significant difference or there is not. All right. Euclidean distance is the geometric distance between two objects or cases. When you do Euclidean distances, the smaller the distances, the more similar the cases. All right, remember this. However, when this Euclidean distance is heavily affected by variables with large size or dispersion differences. Excuse me. Excuse me a minute. So if cases are being compared across variables that have different variances, some variables are more spread out, then the Euclidean distances will be inaccurate. I'll give you an example. Okay. Imagine I'm going to find the arithmetic mean of numbers between 10 and 20. The numbers are 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What do you get? Probably 15 or probably 14 or probably 16. Say I put 21, 9, etc. You will get the middle numbers 14, 15, 16. Now, if I say 15 is the average of this number data set, which is 10, 11, 12, 13, etc., it would make meaning. Okay. 15 minus 5 is 10. 15 plus 5 is 20. X bar plus or minus sigma. All right. 15 minus 5 is 10. 15 plus 5 is 20. All right. Now it would make sense. Now we'll find the arithmetic mean of currently 10. Connect these numbers. 10, 20, 100, 400, 1000. If I take the arithmetic mean of these numbers, 10, 20, okay, 100, 400, 500, 1000. I'm just imaginary telling, I don't have time to calculate. Imagine this, for this data series, your average, arithmetic average would be say 450. Now 450 and 10, no connection at all. 450 and 20, where's the connection? 450 and 1000, is there a connection? In these cases, when the numbers in the data set have a great variation, the arithmetic mean loses its significance. The same understanding you give here for the Euclidean distances. They will be inaccurate when the distances between the variables are very large. Keep this in mind when you do inference. All right. Now, next, sometimes when you use different scales, etc., they say you have to standardize. Like, what is standardizing? Like you make for normal curve, Whenever we give you some data, you make it z is equal to x minus x bar by sigma. That is standardization to find the standard normal curve. All right. So z scores. So you have to standardize using z scores. I'll show you how to standardize, and you can use the centered mean, or you can use the z scores in in SPSS. I'll show you that where to do it. Okay. So you have the Euclidean distance. We choose interval in the SPSS, and we use the squared Euclidean distance. So here we have, you can click this, and there we are. Next we have to use the cluster method. Now, here typically choices are between groups. That is, distance between the clusters is the average distance within the cluster. Nearest neighbor. I taught you single linkage, no, nearest neighbor. A or B should be similar to C. C, the third one. A and B are in one cluster. If C has to join A and B, either A has to be similar to C or B has to be similar to C. Now, this furthest neighbor, that is A or B. In this one, A and B have to be similar to C. And next one, it is average of A and B, like that. So we have the Ward's method. Ward's method I explained to you. Single linkage works best. This you can just read. So Ward's method uses the F-like. So what is the F is equal to? Fisher's test is equal to variance between samples divided by variance within samples. Please remember F test ANOVA is equal to variance between samples, B on top. B comes before W. So I remember that for remembering the formula. Variance between samples divided by variance within samples. So B comes before W in the alphabet, English alphabet. So B is the numerator, W is the denominator. This is my technique of telling students how to remember F. Okay. Here we are. Z minus, see, I could not, I was told day before yesterday to do this class because someone, I think, could not do it. So you have to excuse me small things. I didn't have time, so I had a higher education meeting yesterday and it went on in the evening. So I've done the presentation in a hurry. So here X bar, this one should come on top of this. I didn't have time to, Google and do, so I put X bar. So this standardization, as I told, you can do Z scores or by centering the scale. I'll show you where to click on standardization and where to click for this. Okay, let us go ahead. Now, this is my example. Okay, let me check the time. Yes, I think I have 45 minutes. We'll go slowly. Now, this is the exercise. I'm supposed to do exercise for you on SPSS. I'm sorry, I cannot do it, but I've brought you exact pictures by doing it on my laptop. Okay. Now, typing was done one of my research scholars, so the English you have to excuse me. Okay, all ready? Here we are. We are clustering our data. To classify, we want to classify customers based on their preference towards a particular soap. So there are 9 variables, that is the features of the soap or other similar things, because not everything is recommended by others is not a feature of the soap. So we have given 9 variables here. The 9 variables are quality of the soap, the smell. This is actually fragrance. I'm sorry. I told you my research scholar's English. He's a nice guy, but his English is a little. He has to be trained. Okay, smell. It isn't smell. It's fragrance. Price, offers. Price is the price of the soap. Offers, whatever offers, when you get offers, do you go and buy, like that? 3 plus 1, 4, or 2. Third one is, you get in packets, 3. So that is the offer. Weight of the soap. You want a 150 gram soap or a 75 gram soap. Availability. Water. All right. And then it could be water availability also. And then availability, is it available in your local shops or do you have to go something like this? advertisement, recommendation, etc. So we have the sample opinion from 60 60 respondents. The ordinal scale is used for all the 9 variables, and we have taken already classified. That's why supervised method it is. We have classified it as gender, age, and size. All right. So there's no point in clustering gender, age, and size. If you want to, you can, but just think, you already classified it. All right, and you selected them. So it's like, so when I go for Viva, someone will say, "What's your finding, man? What are your findings?" They say 60% were male and 40% were female. And then I said, "That's not a finding. That's how you selected it. No, you selected it. It's not a finding." So that's what I want to tell you. So here it will be like, if you cluster gender, age, and size, it will be your profiling your own selected profile. But if you want to use gender against something and do correlation, that's a different thing. All right, let's go here. Now, first you have to open the data set values in SPSS. Imagine you have a data file and you called it cluster. So my file, I created one file and I called it cluster. So I'm going to take the cluster file and I'm going to open it. All right. So I'm going to do hierarchical cluster analysis. I have opened the data set values in SPSS. Let's see what happens. Now this is my data set. Okay, this is my file, which we have. Yes, my research scholar typed it for me. I didn't have so much time. Okay, so here we are. You have 60 people. All right, and you have gender, age, and you have gender, age, ID, size, quality, fragrance, price, etc. I hope you are understanding. Okay, next, you click on analyze. All right, when you click, you come down to classify. You want clustering, so it's basically classify. So classify, I will go into hierarchical cluster. All right, we are going to do k-means on the same. I told you my example is two-step clustering. It's a two-step clustering is a combination of hierarchical and k-means. Obviously, I have to do hierarchical first because I need to know how many clusters are necessary, because I have to tell what is k, right? K is equal to number of clusters. How many clusters I want? I have to find how many clusters can be possible through hierarchical. So here I'm clicking on the hierarchical cluster. Next, you will be presented with this box. It says, if you see here, just let me this thing, because I want my 1 minute. I want my file open on my phone as well. So here you have hierarchical cluster. You will be presented with this. See, here it is. Where is the hierarchical? Here, hierarchical cluster analysis. So what do you have to do? You have to transfer all the 9 variables. You see this fellow? He's pointing to the right. Okay. So you go here, block. How many? 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. You've blocked all the 9 variables that you want to cluster, and you click on Mr. Arrow. Okay, the button. When you click on Mr. Arrow here, all these fellows will be shown in this box. All right, let's go on next. Okay, now next you will get, it will look like this. All these fellows came here, and Mr. Arrow will be pointing here in case you want to say, I want to put age there, which you don't. Okay, so here you are. Then we'll go ahead. Next, this is how it will look. Now, click on the statistics button. This is the statistics button. All right. We are going to use plots, method, all these buttons we are going to use. So I have clicked on the statistics button. You will be presented with this, see. All right. And I tick agglomeration schedule. You already, I explained to you what is the meaning of the agglomeration schedule. And in the methods, I have explained to you. So here we don't need the proximity matrix, and rest you leave it as it is. And okay, here you click on the agglomeration this thing, and click on Mr. Continue or Miss Continue. Click here. All right. So here it is. Next, click on the plots. This is the plots button. Click on the plots button. So you'll be presented with a dialog box, and you want Mr. Dendrogram. We loved that dendrogram. I loved it. Okay, it's like I love all those ER diagrams and all. So here and the flow charts, they're so expressive. So in my business analytics book, you will find a lot of these diagrams because I love diagrams, right from Gantt chart, because very expressive. They give you a bird's eye view of everything. They are more expressive than writing in sentences. So you have said click below the dendrogram. You know what's a dendrogram? So here we want the dendrogram, and then you click on Mr. Continue. Next, step 6. Click on the method. I showed methods button was on the right. You click on the methods button. Shall I go back and show the methods button? See here. Click on the method button. So when you click on this method button, you will get, we obviously want the WODS method. Okay. Then you want the squared Euclidean distance. I've explained the WOD method. Excuse me. And I have already also explained what is the squared Euclidean distance. Remember, the square root of the sum of the squares between each data point and the mean divided by n, the standard deviation formula. So you have ticked on the WODS method and the Euclidean distance, and you continue. Click on continue. So we go to the next step. Click on the save button. Here is Mr. Save. You click on Mr. Save. You will be presented with a dialog box, and tick none in this clusters. We don't want anything of this. Okay. You click none and you click continue. All right. Here we are, cluster membership. You click none, and then you continue. So you will come to the next one. This is what, click on the continue button. You will be returned to the hierarchical dialog box. All right. There you say click on OK, and this will generate the output. This is the agglomeration schedule. Now see, you remember we have 60 variables, 60 people, 60 people's opinions. Sorry, 9 variables. We have 60 people's opinion. Here I've given you only so much. I've cut off the diagram because it was when I put the whole thing together, you could not see this properly. See, cluster combined, stage, cluster 1, cluster 2, coefficients. Look at this. Here, stage, all this. All right. So this is how it will look for you. Let us go on to the next one. If you see here, this is the entire table. It is squished, I know, but I have to show you the entire table. So you have 1 to 60 here. All right. 1 to 59, I think. Okay, here we are. Next, I've shown you only the last part of this. Okay. The table I've pushed up so you can see. Interpretation. What is the purpose of agglomeration schedule? To identify a homogeneous group. Now, when you have to see the coefficient values, when the coefficient values have a huge jump, then you have to start thinking. Now, see here, as evidenced by the first large increase in the coefficient values, there is a jump in the coefficient values between 56 and 57. See, here you have 44, 55, 109, etc. With a difference of approximately 43.3 the distance between this one and this one is 43.3, and this is the sudden first noticeable increase. So it tells you to stop after 57. Here the coefficient has suddenly increased from 57 to 59. Therefore, we have 3 clusters. Now don't be so worried about it. We will go and see the dendrogram.
Madam, you're mute. Please unmute yourself, madam.
One minute, I'm trying to share my screen. Kindly forgive me. So, can you see my screen, sir?
Yes, ma'am.
Okay, very sorry. I was so absorbed, I forgot to check whether my Mac was charging. I'm sorry. I'm coming back, guys. I'll this thing. 1 minute. I hope I didn't waste too much time.
No, ma'am, no issues. You can continue.
Yeah, sorry. I'm not like this usually. I was so absorbed in teaching, I forgot to see that my Mac was charging or not. Okay, here we are. Okay, I think we have gone up to here. Sir, you can see, no?
Yes, ma'am. Yes, yes.
Yeah. We were, I think, we just finished this. Agglomerations at dendrogram. I think we finished this. And I was telling you about this. So here we are. See, Clusters using the interpretation. Look at this. Based on the tree graph, there are 3 clusters that are distinctly different from each other. Here, from 35 to 5 is one cluster, see? The line is equal. The vertical line is equal for all these fellows. Then here we have 19 to 49. Where is 19 to 49? Wait, 53 to 6, 6 is here. So we'll go on to 53. Here is 53 and here is 49. So the next one was 19 to 49. This is 49 to 19. And the third one is 13. Wait. 53 to 6 here. Sorry, I got a little flustered. So I'm talking, sorry about saying 13. This one, because it is connected. This one is connected with this one. All right. Here we are. Before K means, this is how you see. After K means, this is all, you get proper clusters with K means. Now, guys, I'm going to do the K means cluster analysis. Again, open the data set values in the SPSS. All right. Okay, we have nearly half an hour. So this is my data file. So here we are. I'm opening this. Next, this is my data file. All right. Let's go on. Again, analyze, classify. We did this one before. So we do the K-means cluster now. Now, again, these variables were all here and Mr. Arrow was pointing this side. So when you take all these, you block them. They were here, you block them and you click on Mr. Arrow, you'll get it here. All right, transfer the 9 variables into the variables box. 1 minute, I'll just get on to my this thing. I want to see on my phone as well, because sometimes this one blocks my view. Okay, here we are. Well, give me a moment, please. Okay, here we are. Step 2, we click analyze, we have done. Step 3, will be presented with the K-means, this one, cluster analysis. All right. Dialog box and transfer the 9 variables, which we have done. Let us go on to the next one. Here the number of, see, look at this. See, by default, you will get 2. Okay. So now we got 3 clusters in the previous one, no? Previous in the, what is that? Hierarchical method. So we got 3 clusters. So we can change this to 3. All right. So number of clusters is here in the K-means cluster analysis. This is the first step. This is the second step. So you click OK and we go to the next one. Click on the save button. Click on the save button. The save button is here. You will be presented with a dialog box like you see below and tick cluster membership here. Cluster membership. All right. And go into continue. All the other boxes can be ignored. Then we come to step 5. Click on the continue button. All right. You will be returned to the K-means cluster dialog box. All right. Then you have to click on the OK button. So this is the, this is all simple. This will generate the output. Now this is cluster centers. You have cluster 1, cluster 2, and cluster 3. Now these are the coefficients. Which is the largest number here? All right. It is called cluster centroids. It is based on high mean value. I'll explain with the next one, then we'll come back. K-means clustering is used to carry out cluster centroids based on high mean value. The 9 variables are grouped as 3 clusters, as you can see. 4 here is the highest mean value in the 3 clusters. We'll go back. You can see here 4. There is 1, there is 2, there is 3, and there's 4. Here 3, 2, 4, and 2. You have 2, 1. Obviously, 4 is the highest mean, isn't it? So we'll come to this one. 4 is the highest mean value in all the 3 clusters. So cluster 1, which variable is high? You look for the highest one. Highest one is 4. So you have, in cluster 1, you have quality of the soap, fragrance of the soap, and nothing else. These 2 are highest in cluster 1. We'll go to cluster 2, look for the 4. Number 4 is here. So in the cluster 2, people want reasonable price. Next one, you have 4, discounts and free gifts. Again, 4, weight of the soap. Again, 4, availability of the soap is important to them. Next one, suitable for groundwater. Like many places in our country, we have sweet water and we have borewell water, which is salty water. This is what it means, in case you are wondering why I put suitable for groundwater. So in cluster 2, you have 1, 2, 3, 4, 5 factors. Now we will go to cluster 3. Only 2 number 4s are seen. This 4 is, this cluster looks for attractive advertisement and it looks for recommendation by others. Take a look at this table again, in case you're looking for, and I think with that, I think my presentation is over. You have, if I go down, these are questions for you guys. You can see this. This is how hierarchical process happens. Like I told you, these points are moved. And you see this line moving so that you get clusters. Red points become blue points. This is how it happens in the hierarchical way of doing. All right. So 2 different clusters are formed. They keep on moving because the iterations happen and you'll get 2 positive, here in this diagram, 2 positive clusters. You have 4 levels of measurement scales, which I did not have time to tell you. So you have nominal, ordinal, interval, and ratio scale. Nominal scale is a naming scale where you have blood type, zip code, gender, race, eye color, something like this. They are labeled. There's no specific order. It doesn't mean, you have to have, like an interval, you have 0 to 10, 11 to 20, like that. It goes in some kind of sequence. But here, there is no specific order. This is the nominal scale. Ordinal scale in a specific order. Low income, then middle income, and high income. Or high income, middle income, low income. Some kind of sequence there is. Similarly, here, income level, less than 50,000, 50,000 to 100,000, or over 100,000, or it could be otherwise. But there's some sequence in the ordinal scale. This is just for in case I'm feeling a little guilty by not telling the scale. Interval scale, specific intervals, I already told you, 0 to 10, 11 to 20, something like that. Ratio scales. It bears all the characteristics of an interval scale. In addition, it can also accommodate the value of 0, like this. See, interval data is measured along a numerical scale that has equal intervals between adjacent values. You can see here 70 to 80, 80 to, no, it is not like that, 80 to 90, this way. Okay, so I will go back. Is this too irritating? I'll
No,
stop
madam,
here.
madam, definitely not.
It's a little irritating, I think.
No, madam,
So,
nothing like that.
can I stop sharing?
Yes, madam. Any queries from participants, you can ask madam directly. You can unmute yourself.
Plenty of queries, sir.
I don't know, like I'm asking if there is any queries.
Excuse me, ma'am. I am Niranjana, a research
Hello.
scholar.
Please talk little loudly.
Can you hear me right now?
Yes.
I'm a research scholar. My name is Niranjana. And I would like you to repeat that K-means cluster analysis, the steps in K-means cluster
You want
analysis once
me
again.
to go back?
Yeah, K-means
Okay,
cluster
okay.
analysis.
Okay, hold on. Hold on, once again.
Okay, okay.
Did I go a little fast, man? Wait.
A bit, ma'am, but I couldn't
One
follow.
minute.
That's why. Okay.
K means, okay, we begin here. Okay, is that correct? Shall I start here?
Yes, ma'am, please.
Okay, so yeah, no problem. I think, you know what, I got a little flustered, man, because I went blank no on this. So maybe I did not explain well. I'm sorry about that. K means cluster analysis we are doing. Okay, so first we open the data set values. My data file was called cluster.sav. So I bring it here and I open it. Next, this is my file. This is how I had done the same file. All right, same file. I have done this. Okay, now I go, this is what I see. I'll go ahead. I have to start analyzing. All right. Oh, guys, I forgot to tell you one more thing. Standardization, I forgot to tell you. I'll show you where to do standardizing. 1 minute before I forget. There are two ways you can do standardizing. You can do it in the first descriptive. You can go into descriptive. Then you can ask for standard deviation. That is one way. The second way is in this screen. I'll show you here. Okay. Good. We are going back. Thanks, Ma. So you classify, then you come to K means cluster. You have clicked this. Okay. Then you come here. Here, this quality of the product, fragrance, etc. was here. So all these 9 variables I block here, and Mr. Arrow was pointing like this one, this side. So I click on this arrow and all those what were here will be seen here. All right. Now we come to number of clusters. Look at this. Number of clusters by default will come as 2. Okay. By default will come as 2. Since we did the previous method, hierarchical method, and we got 3 clusters, now we have to make this 3, but that will be the next option. We go into OK, to this button, we go ahead. We change the number of clusters to 3. Why? Because we got 3 clusters. All right. Then we go into, what does it say here? Save, isn't it? Then we go into this one. When you save, it comes to this one. Just follow it, ma. We put continue. All right. Then we'll come here. Click on the OK button. You will get this. All right. Am I clear? Was it clear now?
Yes, ma'am. Yes, ma'am. Clear. Thank you.
Feel better?
Yeah, yes, I feel better.
Good. I will just run it again if you want. I guess there are very few steps in this method, and that's why you are a little worried. Hardly 2 or 3 steps, isn't it? As compared to the previous one. Maybe this was what you're worried. I will send you the presentations. Okay. But please remember, guys, I'll stop sharing, sir. Please remember that this is only an initial, one. Yeah. Okay. I've done something I cannot see. Okay. I hope wait, let me see the chat. Anything for me? Anything, sir? Deepjyotish, sir, anything for me?
No, I guess no.
Annapurna, I'm glad. Thank you, Annapurna. Sir, today I didn't get nice, nobody has written nice sessions, sir.
They will write it. They are waiting, madam, to finish the session.
Last time so many said good session, no? Today I didn't do well, is it?
No, it is not like that. Maybe everyone is exhausted. This is the last session of the program.
Oh, yeah. Anyway, love you all, guys. Thank you so much.
I quickly request Vicky ji to provide the vote of thanks to madam.
Thank you so much, sir. Thank you so much, Dr. Deep Jyoti.
It's only 2 o'clock.
Yes, madam. No issues.
Nobody wants to ask anything.
No, like they are maybe tensed for exam because next session there is evaluation.
Oh, I'm sorry. I wish you all the best for your exam. I'm sure with the excellent resource persons that Sir Deepjyoti sir has provided, I'm sure you all be doing very well. Thank you.
Number of appreciation are coming now in the chat box. You can see if you want.
Yeah. Okay, sir. Let them answer the exam, sir. I won't disturb you.
Exam is at 3 p.m. not now, madam.
Okay. I'm very glad. You know what? I love this comment, that you got the clear idea and all that. I'm very glad. Thank you, sir. Because as a teacher, I feel happy if there is a feedback. Okay.
Surely.
Thank you. Wish you all the best. God bless all of you.
Vicky ji, please. Vicky ji.
Yeah. Thank you, sir. Thank you to Dr. Deepjyoti sir, Assistant Professor in the Department of Management, Assam University, Coordinator of this online FDP, Research Methodology and Techniques and Software for the Social Science SSP-based Advanced Level, sponsored by Atal Academy for AICTCE. My vote of thanks for the today's second session for the esteemed speaker, Professor Cynthia ma'am, is a professor in the Department of Management, University of Bangalore. Thank you so much, ma'am, your entire session, because we really are curious about to learn things. But you are explaining each things are very detailed, are very systematic in order. So it's very crystal and clear. It's very laudable, and it is my privilege to be just giving the vote of thanks to you. And thank you so much, ma'am. Once again, the things are very clear. How to be just manage the scales and what the things you have to be take care of when you doing such kind of cluster setting off. So it is very useful for the young researchers like me and those who are very much interested in the field of research. Thank you so much, ma'am, once again, and thank you to Dr. Deepjyoti sir to be sharing the opportunity to me to giving the vote of thanks for such a great extreme faculty to be the speaker over it. Thank you so much, ma'am, and thank you so much,
Most
sir.
welcome.
Thank you, Vicky ji. Thank you, madam. I was wondering how could you prepare this session in entire
we are implementing national education policy in the state, no, sir. So we are implementing national education policy in our state.
Okay,
so that
madam.
is why I'm in the high power committee, also in the BBA committee. Also, I'm the coordinator for NEP of my university. That's why, I had a little difficulty. But for you, yes.
I was wondering, madam, how could you finish the entire?
I slept at 3 a.m. sir today.
And on my single request, you just agreed to take the
Sir,
session.
we are teachers. We have to support each other. I slept at 3 a.m. I'm going back to sleep now.
So sorry,
But I'm
madam.
glad. See, we should not confuse people. We must convince them. And if I've done that, I'm very grateful. As a
Thank you,
teacher,
madam.
I'm humbled.
You have given full
Thank-
justice. You have given full justice.
Thank you, sir. Thank you. All of you, all the best. Nice meeting you all. Take
Thank you.
care. Namaste. Shall I leave, sir?
Thank
Okay,
you so
madam.
much, ma'am. Bye-bye.
Jai Hind,
Jai Hind.
everyone.
Jai Hind. So participants, we are leaving now. We are coming to the end of this session. So we'll be back at 3 p.m. At 3 p.m. there will be MCQ exam, and that will be shared in Google form. The link of the Google form will be given in the chat box. You be straight, maintain the time and come at 3 p.m. in the meeting. Thank you.